Hey 7th graders, today again you'll be doing another little modified lesson of Amplify. So again, hopefully you guys are watching this video and catching on. It will benefit you. Mainly today, the first thing you guys should have done on your Teams post is gone into your OneNote and added key concept 2, 3, and 4. So yesterday, or in yesterday's lesson, you guys added this key concept here. So the function of a protein molecule depends on its structure and how it interacts with other proteins. So basically what you guys saw is that you had different types of proteins in your little activity, and you saw how they had different structures, right? So this one had 2 connectors, this one only had 1 connector, and then this one had no connectors at all. So they all have different structures. What you guys were able to see is if we were to put those together, those separate protein molecules, to form a longer chain, okay, how might those different individual molecule structures affect their overall function? So in this case, the function we looked at was flexibility. So because of its different structure, how did that affect the flexibility or function of those different proteins? Okay, so that's a big concept for you guys to understand, is that we have all kinds of different shapes, and especially with proteins, you know, if we have a different shape, it might have a different job to do. Maybe we have a mutation that makes a different shaped protein than it's supposed to be. It might not have the same job or do the same job as it's supposed to be, and it might not be effective. Okay, so if anyone knows anyone with maybe cystic fibrosis, you guys have a protein in your lungs that helps get fluid out, basically. If you have a genetic mutation, it could make a different protein that doesn't have the same shape, and therefore it doesn't get the fluid molecules out. So someone with cystic fibrosis constantly has to get the fluid out of their lungs, or basically they could suffocate and die. There's a lot of good treatments for that now, but it is still an issue, obviously, with someone living with cystic fibrosis. But all of that comes because the protein that they were supposed to make in their body has a different structure and therefore doesn't function properly. Okay, to add to that though, you guys have 3 more key concepts today that we'll look at. So differences in the structure of a protein molecule affects how they connect to other protein molecules. So again, you guys saw that yesterday when we were able to connect those individual protein molecules. So because of the structure, they connected differently. This can result in different traits. So different jobs or different functions could also lead to something like different traits. For instance, your eye color, however that may look. Okay, number 3, the structure of a molecule determines how they function on a molecular scale, which determines the properties of the object they make up. So different makeups like this could, different structures like this could affect how they make up their overall big structure. So in the case that we're going to talk about today, we're talking about spider silk flexibility. So if this were the protein for spider silk, okay, on a molecular scale, we might just look at one of these little molecules. Okay, but if we were to take a bunch of these, millions and millions of these molecules and put them together, that could change a whole different trait for an organism. In terms of a Darwin bark spider, it might be how flexible their silk is of that spider, and it might influence the purpose of that silk. So you guys read about those 4 different articles where you might have one that shoots venom, or one that can stretch clear across a riverbank, or even one that can help a spider fly away and be mobile. Okay, and then finally, organisms can have different proteins in their cells for a particular feature. So just because we have this one protein for our spider silk doesn't mean that like a protein for a venom would be the same shape. Okay, we have a completely different protein for that controls it, and again, that's all controlled by our DNA or instructions how to make that protein. Okay, so those are our 3 concepts that we're going to kind of go through today. So at the end of today, you guys should be able to explain these 3 key concepts. Okay, so first thing first is once you guys have added those 3 key concepts into your note, you guys are going to go into Traits and Reproduction, Chapter 1, Lesson 1.4. The only thing you guys are going to complete in this activity is the warm-up. So we just did a pretty good review to help you guys answer this warm-up question, so you guys can see this little family tree, or what we call a pedigree, for Darwin bark spiders. So you can see parent 1 might have low silk flexibility, meaning it's not very flexible. Parent 2 might have medium. So if they were to mate and have offspring, you can see that this is a possibility for our offspring. One could have low silk, medium, low, and high. So even though neither of the parents are high for their silk flexibility, they could still produce offspring with high. So we'll talk about that later. That's for a different chapter. But for now, you guys have this word bank with the term molecule, protein, trait, and structure. Okay, so what have you learned so far about why some of the Darwin's bark spiders have different traits for silk flexibility? So again, you see low, medium, and high. So explain that. What have you learned so far about why they have different traits? And then use those for vocab terms to explain your answer. Okay, pause as you need. And then once you're done with that, we're going to go ahead and move on to the part 2 simulation. All right, so go ahead, click on part 2. The only thing you need out of this is the simulation link. You guys are not filling out anything else in Amplify today other than that warm-up that we just did. Okay, so go ahead and open your traits and reproduction simulation. It looks like this. And then you guys can just exit out of Amplify. Okay, go into Teams Assignments, and today you guys are gonna find this lesson 1.4, 1.5 simulation called How Protein Affects Traits in Bark Spiders. So we're gonna look at some different proteins and how they affect different traits. So the first trait we're going to look at is silk flexibility. So I just want to show you guys a couple things. You guys can go ahead and pause right now. This is the first time really jumping into this simulation. So take a second and just kind of explore different things you guys can do with it and click on the spiders, check them out, find what you guys can see with them. Go ahead and pause now. Take about 2-3 minutes to explore and then come on back and I'll show you guys some things I want you guys to look for today. Okay. So welcome back. You guys hopefully notice that up at the top you guys have different traits you can look at. So in this none, it just means we're not looking at anything specific about the spiders. You guys can also look at silk flexibility. So if I click on that, I can see now I have something for silk flexibility. We have this little letter number combination F1, F1, F2, F3. We're going to get to those in later units, but right now let's just look at the trait. So for each trait, these are your traits up here, you have different variations. So as I'm looking through these, I can see, all right, Greg here, okay, it's an appropriate name for a spider that's probably going to kill me, or not, we don't know unless we click on Venom. But at any rate, Greg here has low silk flexibility. So again, when I say low silk flexibility, I mean it's not very flexible. It's not necessarily brittle because it is still spider silk. Zora has high. And Leo is a male that has medium. And then you guys can see that's really all there is for different variations of that trait is low, medium, and high. Okay. You guys can also see there's silk stickiness. So it looks like we have, for variations, sticky, not sticky. So it looks like there's only really 2 variations there. Venom, we can see Greg is a stunner here. Zora, she's pretty docile. She has no venom. And then Leo, on the other hand, kills. So you guys can see, again, those variations for venom. Bristle, we have none, dense, or sparse. So 3 variations there. So no bristles on their legs. Really dense. I mean, they got some hairy legs. Zora needs to go shave. And Leo is sparse. Okay. Always seems the guys have less hairy legs than the girls. Jerks. All right. Anyway. And then we can look at size. So we have smaller versus large versus medium-sized spiders. Body color, we've got yellow, brown, and colorless. I would hate to run into Anne. She kind of freaks me out. And finally, stripe color, we've got the red stripes, black stripes, purple stripes, and blue stripes. So we actually have 4 variations for that one. All right, so let's go ahead and go back to silk flexibility. What we know is DNA is a really important molecule in our body, and I really try to emphasize this point with you guys, is DNA is cool and all, but it doesn't make us who we are. Okay, proteins make us who we are. All DNA is an instruction on how to make those proteins. But again, I can't emphasize this enough. Your whole body is pretty much made out of proteins. Okay, so if you didn't have a good instruction for DNA, you're not gonna have good proteins built. They're not gonna have the right structure, and therefore they're not gonna have the right job or function that they're supposed to complete. Okay, so what we're gonna focus on in today's simulation is these different proteins and how they influence this trait of silk flexibility. So let's go ahead and just take a look at Zora here. Okay, so if I click on Zora, it shows me one of Zora's cells. Okay, and then inside of that, you guys can see this little key at the bottom. These tell me which proteins that Zora has. So we know that Zora has high silk flexibility, meaning her silk is super flexible. Okay, it's these proteins that we find in Zora's cells that make up those silk fibers. Those shape of those proteins are why her silk is so flexible. Okay, she's gonna have different proteins in her cells than someone with, say, low silk flexibility, or a spider with low silk flexibility. So let's just take a minute really to look at how these would even come together, how these little protein molecules would even come together to form silk. So if you guys were to click on this little protein to trait example, you can see, all right, we have these little proteins being produced inside cells, and then they're kind of secreted outside of the cell. So you guys can see, if we go back to this, you had in Zora's cells, this type 2 protein, just kind of like how we had our type 2 protein for silk, okay? And very similar, again, a type 1 protein, okay? These aren't an exact replica of what this is supposed to look like, but it's a pretty good visual representation. So she has type 2 and type 3, okay? In the example that you got here, you can see that this spider, whatever spider it is, has type 3 and type 2, okay? It doesn't matter necessarily what type we're looking at here. This just shows us how those proteins come together to form silk. Okay, so again, we have the cells producing those different proteins. They're secreted into this duct. A duct is basically like a channel or a roadway inside of our body, or in this case, inside of the spider's body. So the cells produce those, they secrete them into the duct, and then all those proteins out of all these millions of cells go into the duct and start going towards the end of the spider, which we call the spinneret. Okay, so you guys can see how these proteins are starting to kind of almost zip together. So you can see how there's little notches, and they're kind of fitting in there together to form silk. So here's the silk coming out. This is one thread of silk right here. There's obviously multiple that come together to form something that's visibly, we can see it. Okay, and then here's a bunch of different silk strands shooting out of a spider's spinneret, and it looks like they kind of have a lot of different spinnerets around as well. Okay, so this is where our silk comes from, and you guys again can look and see how these little proteins come together to form silk. Okay, if I exit out of that, again I can look and say, all right, Zora's variation for this trait is high silk flexibility. So that comes from her using type 2 protein and type 1 protein. Think about what we did in the last lesson where you guys had these little connects and they were able to connect to other molecules, okay? Think of how these different proteins that you guys see on the screen here might connect differently, okay? You don't see a whole lot of connectors on 1 or even 2. Or excuse me, 2 and 3. So 3 really doesn't have any connectors, and 2 only has the little ends there. So how might that influence the fact that Zora has high silk flexibility? Okay, something for you guys to think about. All right, so let me go ahead and explain today's assignment for you guys. So if you go into Teams Assignments, again, you find how proteins affect traits in bark spiders. Your first task is to just look at a couple different traits starting with silk flexibility. So it says, all right, let's start here with silk flexibility. Let's choose 3 different spiders with differing variations. So pick one that's low, medium, and high. So you're going to go back. We're going to exit Azora here. And you're going to say, all right, maybe I do Anne. Anne's my low. Okay, Ruby's my medium, and Otis is my high. Okay, so I would maybe fill out some information for Ruby. I would say my spider's name is Ruby. Her silk flexibility is medium. So I'd go in here and type in medium. And the protein molecule structure. So I'm looking for the numbers here. So what proteins does she have to make her silk? So if I look at her picture, it looks like I see protein 1 and protein 2. Okay, so I'm going to go in here and type in 1 and 2. Okay, now pick a spider with low and pick a spider with high. Okay, type in their information. I just went through this protein to trait with you guys, but examine the diagram again if you need to. What protein numbers are the silk flexibility proteins? So we kind of just looked at that by looking at any of the cells and looking at the key. Which 3 proteins make for different silk flexibilities? Okay. And then what you're going to do for the next part is you guys are going to choose 2 more traits. So don't forget to answer question 2 here. How might the differences in proteins lead to different variations? Again, we've talked a lot about that just with looking at these examples and going through the simulation. So on the next 2 tables you see, so right here, so choose 2 more traits down to question 5. And then again, this table to question 8, you guys are going to pick 2 more traits. So if we go back into this, you guys have these other traits up here. Silk stickiness, venom, bristle, size, body color, and stripe color. To study 3 different spiders. So again, you're going to want to pick something that has more than 2 variations. So I think all of them, but maybe 1 had 2 variations. So pick some that have different variations. So your options are silk stickiness, venom, bristle, size, body color, and stripe color. Choose 1 spider from each variation. So maybe I choose to do venom. I see I have stuns, no venom, and kills. So I'm going to pick a spider that can stun, a spider that has no venom, and 1 that kills. Okay? And then again, I'm going to click on those, and I'm going to look at their different protein shapes and say, all right, here is possible proteins for venom. They can either have 1, 2, or 3. Which one does Leo have? So it looks like he just has protein number 1. So I would fill out the information for a spider that can stun, a spider that can kill, and a spider that has no venom. Trait I studied, I would have maybe chose venom for that, so I'd type in venom here. And then click on protein to trait on the left-hand side, examine the diagram. What protein numbers influence your trait? So again, you guys can see that there's 3 proteins here that influence your trait, but we can also pull this together to say, all right, here's how the venom proteins kind of work. The cells produce them, they go into a duct just like we saw with the spider, and then those different proteins can form different venom, okay? So there's some venom proteins, and that might give us some venom right there. Okay, so there's different combinations. Obviously, you won't see that every spider has venom, so you might see some other spiders with different variations. All right, so you guys will choose that and finish these questions. How might the differences in proteins lead to different variations for your trait? And then choose another trait. Do the same thing. Then we're going to move on to lesson 1.5. So again, there's nothing for you guys to fill out and amplify 1.5. You're doing it all on here. Same thing, though. Let's talk about if we were to possibly change these variations. So let's go in, and we're going to choose Greg, and we're going to say, all right, Greg has silk flexibility here. We can see he has nothing but protein number 1, so he probably has a pretty low variation for his silk flexibility, so not very flexible silk. Okay, what do you guys think would happen if we were to add different proteins? If we could change his DNA and make different proteins show up in his cells other than protein number 1. Okay, so you guys will make a prediction on that. So Greg's silk flexibility trait, we know he's low. What protein number does he have? He has protein number 1. So prediction number 1, do you think adding more of protein number 1 to Greg's cells would change Greg's trait? Why or why not? So he already has protein number 1, and that's all he has. If we were to add more of protein 1, do you think that would change his flexibility? Prediction number 2, do you think adding protein number 2 to Greg's cells would change Greg's trait? So now if we went in and we were to add this type of protein, would that trait change his trait? And finally, question number 3, or prediction number 3, do you think adding protein 3 to Greg's cells would change his trait? So protein 3 was this one that had no little connectors on it. So make your predictions, and then you guys are actually going to test them. So your white one is your predictions, your gray one's going to be your testing. So now go ahead and add protein number 1. What happened? Reset it. So you guys can add them just by clicking and dragging. So it might take a second. So once you guys have done that, you'll see this blue circle. It's counting down to see if there's any changes. Okay, once that blue circle disappears, you guys will see if there's any changes. If we look, it says, all right, our trait is still low. Okay, if you guys go ahead and reset it, go back in, Here we go. I can just reset right there. Go back in. Now what would happen if I changed protein number 2? Okay, now I have protein 2 starting to circulate. You guys can see it in there. Still hasn't quite circulated enough to change our silk yet, but now it has. Okay, so once it's in there, you guys can see it has now changed. The star means you guys have changed it in some way. So by adding. So even if we added all of protein 1, you guys saw that star show up. So once that star shows up, you guys kind of know what's going to happen. Okay, and then again, reset and tell me what happens when I add protein 1. Okay, and then now go test out Ruby. So I can let you guys kind of figure out the rest of these instructions. You guys have Ruby. You guys are going to look at her body color for trait, observe her traits and her proteins, and make predictions and test your predictions. Okay, Otis is going to be your guys' last little test subject here. You guys are going to be looking at stripe color. You're going to go in, observe what he normally has for his proteins and what his trait is for stripe color, and then go ahead and make a prediction and then test your prediction. Okay, if you guys have any questions, let me know when you finish this up. Turn it in. I hope you all are having a wonderful day, and I will talk to you soon. Bye.